So guys, I want to welcome you to homework number 3. This is the first problem for homework number 3. It says ball 1 is thrown into the air and it follows the trajectory for projectile motion shown in the drawing. At the instant it is at the top of its trajectory, ball 2 is dropped. So ball 2 wasn't dropped until ball 1 was at the top of this point. And we know when ball 1 is at this point, on its way down, it possesses both a horizontal motion and a vertical motion, which are all independent, both independent. And the vertical motion of this ball 1 is exactly the same as the vertical motion of this ball 2. So it says, which ball has the greater vertical component? There is none, they are actually the same. The vertical component from this point to this point is the same. So both balls have the same vertical component. That would be the correct answer. Ball 2 has the greater vertical component. No way. There is not enough information. We have enough information. And ball 1 has the greater vertical component. That's not the correct answer too. Okay. Alright. While I wait for the next problem, let me wipe this off. It's right here. So okay, I can as well just prove to you why the vertical components there are the same. I'll just do it right here. For those of you who might have a problem trying to understand why dropping a ball and throwing a ball horizontally from a height will have the same vertical motion. Let me grab my markers. Sorry about that. It's okay.
We're just need these right now for a meeting.
Oh, I see. Okay. Alright, so let's drop a ball from a height, say y naught to y final, okay? So I'm going to say y final minus y naught equals v naught t minus half gt squared. So it's falling, so v naught is 0, so this becomes 0, so y final minus y naught is just minus half gt squared. So y final is 0, y naught is the initial point I call h, equals minus half gt squared. So minus h equals minus half gt squared. The negatives cancel. So the time of flight is square root of 2h over g for a freely falling body. Is that okay? For a body falling freely. So now let's see, when you project an object horizontally, it has only v naught x. The object falls like that. Considering the vertical motion, v naught y is 0. Is that okay? And then I want to get h also. So I will say y final minus y naught, which is h, minus h equals v naught y t minus half gt squared. So it only has v naught x. V naught y is 0 because it's moving horizontally at that point. So this goes to 0. I have the same thing, minus h equals minus half gt. So I have the same time. They're going to reach down the same time. The vertical motion is the same. Absolutely the same for both cases. Okay? All right. So let's go to the next problem. The next problem says a ball is thrown vertically upward. That is a problem 46, chapter 2. Which is the positive direction. A little later, it returns to its point of release. The ball is in the air for a total time of 7.53 seconds. What is its initial velocity? Neglect air resistance. So we're looking for the initial velocity, and we are given the total time of flight. Okay, now let's do this. So since it's returning to the same spot, so there are two equations I can use to get this. Is that okay? I can get this in two ways. The first way is to assume, so this is method 1 to solve the problem. So we know when you project an object vertically upwards, it comes back down. So long as it hits the same spot it started from, your V naught is your V final. The same magnitude, they have the same magnitude. But V naught is positive, V final is negative because it's coming down. So if you are going up, your initial velocity is positive. When you're coming down, your final velocity is hitting the ground is negative. So I'll use this equation that V final is V naught minus GT. So I know my total time. So I have it that GT is V naught minus V final. Okay? So what is the time? They're asking me for V naught. So V naught equals GT plus V final. So let's do that. But V final is just minus V naught. It's the same magnitude but opposite direction. Plus GT. So that is the trick for this first method. Knowing that your final velocity of striking the ground, so if I throw an object up with 20 meters per second, it's going to land the same ground with 20 meters per second at the same place. But if I throw from the top of the table and it goes to the floor, it won't have the same velocity because it didn't land on the same datum level. So if it lands on the same horizontal level, your initial velocity and your final velocity are the same. In magnitude, you just change the sign for direction. Going up is positive, going down is negative. So minus V naught comes here. I have V naught plus V naught equals GT. So V naught equals GT over 2 because this becomes 2 V naught. Is that okay? So I divide both sides by 2. So GT over 2 is 9.8 times the time given 7.53 divided by 2. So I do that and let me see if I get 36.9. So let me get my calculator really quick. I put the answers there so we can easily cross-check our work and make sure we're doing it right. So I'm going to do on my calculator 9.8 times 7.53 divided by 2. 36.8. Oh, 36.89. 36.9. Very correct. So this gives us 36.9 meters per second. So that's my initial velocity. That's my final velocity. Is that okay? So the initial velocity is 36.9. And that's the same as my final velocity in magnitude, okay? So if they ask me for the final velocity to be minus 36.9 meters per second, the minus just tells you it's falling down. The next problem says the greatest height reported for a jump into an airbag is 99.4 meters by stuntman Dan Koku. In 1948, he jumped from rest. So let's start solving the problem. No time to check time. There is no time to waste. You're going to go with the speed of light. And make sure you get the answers right. So you start from rest. V naught equals 0. So he's falling down. Is that okay? And 99.4 meters. Is that okay? 99.4 meters. That's how he jumped. The height he jumped. H. So this is your Y initial, this is your Y final. Okay? Now, he struck the airbag at a speed of 39 meters per second. So there was air resistance. Now the question is, if we neglect air resistance, determine how fast he would have been moving. So let's compare that. So we're looking for VF of striking the ground, ignoring air resistance. So we'll do V final squared equals V initial squared minus 2G Y final minus Y initial, okay? So V final squared is what we're looking for. V initial squared is 0 minus 2G. Y final minus Y initial is 0 minus 99.4. So I say V final squared equals 0 minus 2G, 0 minus 99.4, minus minus becomes plus. So minus 2 times 9.8 times minus 99.4. So that becomes 2 times 9.8 times 99.4. So my V final is the square root of all this guy. 2 times 9.8 times 99.4. That becomes my V final, square root of that. So I do that. 2 times 9.8 times 99.4, 1,948.24. So I do the square root of 1,948.24. And what's the square root of that? 44.13. 44.138. So that's 44.14 meters per second. So that would have been higher than the 39 meters per second he landed. So if we ignore resistance, air resistance, we're going to go faster. So air resistance actually slowed him down a little bit by about 5 meters per second. About that. Okay. Let's go to the next problem. So that was chapter 2, problem 43. Now let's go to the next problem. I hope you guys can see these questions clearly. Yeah, I think so. Nice. Next problem. Next problem says, two identical pellet guns are fired simultaneously from the edge of a cliff. These guns impart an initial speed of 37.3 meters per second to each pellet. Gun A is fired straight upward with the pellet going up and then falling back down. Okay, eventually hitting the ground beneath the cliff. Gun B is fired straight down. In the absence of air resistance, how long after pellet B hits the ground does pellet A hit the ground? Okay, so there are two methods to solving this problem. Oh, I told you there were two methods to solving the previous problem. I didn't give you the second method, okay? Let me go back to that and give you the second method. Let me go back to that so you guys understand. So this is the problem that was asking for the initial velocity given the total time of flight. That's problem 46, chapter 2. Let me give you the other method to solve that, and then I'll go to the next problem. And then that problem I was working on, I will do the two methods. Hopefully I don't forget. I'm getting old. I start to forget too much. Okay, so we are giving only the total time it takes. We're looking for V0. So it goes up, back, down. We're looking for V0, and we are giving the total time to be 7.53 seconds. So I'm going to use y final minus y initial equals V0 t minus half gt squared. So it started from y equals 0, y initial 0. It ended in y final 0, from 0 to 0. So I say 0 minus 0. Let me see if I have a better marker that writes better, so you guys can see clearly what I am saying. So 0 minus 0 equals V0 t. We're looking for V0. V0, this is almost the same. T is 7.53 minus half times 9.8 times 7.53 squared. So 0 equals 7.53 V0 minus half times 9.8 times 7.53 squared. So let's do that in our calculator and see what that gives us. I hope this red marker works better. Okay. I need clearer markers now. So half of 9.8 is 4.9. Let me do that really quick. 9.8 divided by 2, 4.9 times 7.53 square, 227.834. 227.834. 277. So 7.53 V0 is 277.83441. So what is V0? 277.83441 divided by 7.53. So let's see if it will give us the same answer. So this divided by 7.53, 36.89, 36.9, the same. 36.9 meters per second. So whichever method you use, you get the same answer. So if this is easier for you, if the first method I did is easier for you, you get the same thing. So we've done this cocoa guy. So let's go to the next guy. So this is the problem where on the two identical pellets. Is that okay? So they have the same initial speed. So let's solve the problem for the two identical pellets. So one of them from a cliff is shot up and goes down. The other one is shot straight down. Is that okay? The other one is shot straight down. So this is gun A and this is gun B. Straight down. So they say, what is the difference in time? So definitely we know gun B we get to the floor before gun A. But what is the time difference? So there are two ways to calculate this. The first way is to calculate the total time for this guy, calculate the total time for this guy, and take the difference. Another way to do it is to understand that from here downwards, A and B have the same motion. So just calculate the time for only this part. That will be the difference. The time for only when A was at the top before it started falling from the same level. So I'm going to do both. So let's calculate the time for A. The time for B takes the difference. Or we calculate only the time from here to here. I'll call it from X to X prime. That will give us the same time. So let me do it the first method. So the first method is just to calculate the total time of flight for A. So total time of flight for A, I get y final minus y initial. So I'm not giving the, I'm only giving the, what's it called? I'm only giving the initial speeds. Sorry, let me silence my phone. I hate that. I'm only giving the initial speed and the cliff. I'm not giving any other information. Okay. Okay. So I can get the total time of flight given the only initial speed, but this one will be difficult. Y final minus y initial equals v naught t minus half gt squared. So I don't know my y initial in this case. So I don't know the height of the cliff. So this method will be difficult to solve to get the time of flight. So this method will not work. So which method will work? Let's try this method where it starts from here and ends up here. So if it starts from here and ends up here, I know it starts with a velocity of 37.3 meters per second. I know it will end with a velocity of 37.3 meters per second at the same spot here. So I can use V final equals V initial minus G time. I'll call it small t. Small t is the time to go from here to here. So V final is minus V initial equals V initial minus GT. So minus 2V initial is GT, is minus GT. So this cancel, T is just 2V initial over G. And that is the time difference that we need. So the second method will not work because we don't have too much information. Except we want to combine equations. If we combine equations, it might work. If we combine equations, it might work. But it will be too much work for us. So this is the simplest one to do. So the time to go from here to here is the time difference between A and B. Okay, is the time difference between A and B. Is that okay? So that is 2V naught, 2 times 37.3 divided by 9.8. So let's do that on our calculator. 2 times 37.3 divided by 9.8. $7.61, correct. That's the time difference. 7.6 seconds. As easy as taking a Fanta. So let's go to, that was problem 47, chapter 2. We go to problem 14, chapter 3. Problem 14, chapter 3 says, a tennis ball is struck and departs from the racket horizontally with a speed of 26.4 meters per second. Once you hear horizontally, remember the equation I just proved to you, horizontally, the time of flight is square root of 2h over g. So if I shoot something horizontally, the total time of flight is that. And if they ask you h is the height, if they ask you to find x, since it's shot horizontally, x is just v naught x times the t you got from here. These are the two equations you need for horizontal projection. Nothing else. Nothing else. So the ball hits the court at a horizontal distance of 19.4. So I'm giving this to be 19.4 meters. And I'm giving v naught x to be 26.4 meters per second. So since it's horizontally, I can only have v naught x. I cannot have y at all. Only x. Y, v naught y is 0. That was how I got this equation. So only v naught x exists. So what is the question? How far above the court is the tennis ball when it leaves the racket? So I'm looking for h. So I know t is that, so I put it here. So my x is v naught x times t square root of 2h over g. So from here I find h. X over v naught x is square root of 2h over g. So 2h over g is x squared over v naught squared. I square both sides. So what is h? H is g x squared over 2v naught squared. That solves the problem. 9.8 times 19.4 squared divided by 2 times 26.4 squared. So I do that, and that gives me the answer. So let's do that and see to make sure we get the answer correctly. 19.4 square times 9.8 divided by 2 divided by 26.4 square. 2.646 seconds, exactly. 2.646, sorry, meters, not seconds. We're looking for the height. This is the height. How far? So this is not seconds, it's an error. That is 2.64 meters, not seconds, for the height. Okay, let me fix that right now. That's 2.64 meters, not 2.64 seconds, okay? 2.64 meters. Okay, fixed. So let's go to the next problem. Next problem. Oh, did I miss something? Yes. I jumped one. So question 3, problem 15. Chapter 3, problem 15. A skateboarder shoots off a ramp with a velocity of 7.5 meters per second, directed at an angle of 54 degrees above the horizontal. So the end of the ramp is 1.1 meters above the ground. Let the axis be parallel to the ground, the x-axis parallel to the ground, the y direction be vertically upward, and take as the origin the point on the ground directly below the top of the ramp. So this is a simple problem, but this is the problem where you take note of the x component and the y component of your velocity. The x component and the y component of your velocity. So we are having this skateboarder who shoots off a ramp. So there is a ramp right here. So this skateboarder shoots off and lands like that. So this ramp is 1.1 meters high. So this is going to be my y initial. So he shoots off with some velocity at some angle theta. So the velocity is 7.4 meters per second. So this is my v naught. And my theta is 54 degrees. Okay. How high above the ground is the highest point that the skateboarder? So we're looking for, I'll call this my y final. How high above the ground? So I'm going to do y final for the A part minus y initial equals v naught y, not just v naught, the y component. Because this v naught now has an x component and a y component. So the v is going at some angle. So it's going to have x component and y component. So I'm going to have v naught x and v naught y. So if I'm solving anything with y, I will use v naught y. So v naught x is v naught, so this is 54 degrees. V naught cosine 54 degrees. And v naught y is v naught sine 54 degrees. So I need to take note of this. So if they ask me to find the horizontal distance, I will use v naught x for everything about x. Now I'm looking for height, I will use v naught y t minus half gt squared. And I also note gravity only affects y. Gravity does not affect x. So if I write an x equation, say x final minus x initial, the same equation, v naught xt minus half gt squared part will vanish. This does not affect x. So x equation will stop here. Y equation we have everything. But x equation will stop here. That is how you know how to work these problems for projector. Okay, but now we are doing the y part first. So let's continue for the a part for the y. So from here, my y final is what I'm looking for. Minus y initial 1.1 equals v naught y is 7.4 sine 54 degrees times t minus half times 9.8 times t squared. Is that okay? Is that okay? Good. But now, let me see. Oh, good. I don't know what t is. So without getting t, I cannot get my y final. But I have another trick. I know that v final squared is v initial squared minus 2g y final minus y initial. So since this equation can work, this equation will work because I have V initial, so this V final Y, V initial Y. V final Y at that spot for the maximum height is 0. So that is 0 equals V initial Y, 7.4 sine 54, minus 2 times 9.8, Y final minus 1.1. Aha! Now this one solves the problem. If I had the time taken to reach that point, I would have used this. But this cannot work. So this will not work. So I'm using this one now. This will work because I have everything apart from Y final. So let me do that. 2 times 9.8 times Y final. So let me do 2 times 9.8 in my calculator. 2 times 9.8, that is 19.6. So I have 19.6 Y final equals 7.4 sine 54, 5.987 minus, or now it becomes plus now, plus 1.1 times 19.6. 21.56. So Y final is this plus that. 21.56 plus 5.987. 27.547 divided by 19.6. Okay? Divided by 19.6. That gives me 1.4. 1.4. Let me see. 1.4. Huh. So let's see if we make a mistake somewhere. Oh, this is V initial Y square. So I'm supposed to square this. That's why I made a mistake. V initial Y squared. I didn't square that. So 5.987 squared. See why I have the answers to cross-check? So that's 5.987 squared. 5.987 squared. 35.844 plus 21.56. 57.404. So this is 57.404 divided by 19.6. 2.93. Now we are correct. 2.93 meters. Now we got it correctly. Now that is correct, okay? Now the second part is, when the scalar ball reaches the highest point, how far is this point horizontally from the end of the ramp? So they are looking for how far this point is from here to here. So I'll call this x naught and x final. So we're going to use the x equation now. So let's go to the x equation. So I'm going to use the same thing here. Okay? The same process. Let me wipe this off. For the b part, so for the b part, we are looking for x final minus x initial equals v naught xt minus half gt squared does not affect x. But we don't know the time, we know v naught x. So it is 7.4 cosine 54 times t. So we need the time taken for this guy to reach up here. Once we get that time, it's the same time taken along the x here to here. So how do I get that? So I go back to my y equation. I use the equation vfy equals v naught y. Sorry, I mixed I and naught as initial. Just get used to that, okay? V naught y minus gt. So at the top, v final y is 0. V naught y we know is 7.4 sine 54 minus gt minus 9.8 times t. So from here I can get t. So t is 7.4 sine 54 divided by 9.8. And what does that give us? 7.4 sine 54 divided by 9.8. That's 5.987 divided by 9.8. 0.61. 0.611 seconds. So I put 0.611 seconds here, and then I can get my x final minus x naught. So x final minus x naught becomes 7.4 cos 54 times 0.611. So let's do that. 7.4 cosine 54. 2.65. Oh, sorry about the signal. Let's check the answer, make sure we are right. Yeah, 2.65, that is 2.66 showing here. Let me take care of that. 2.66, 2.657, so 2.66 meters for the B part. So that's the answer for the B part. 2.66 meters, okay, for the B part. Okay, let's go to chapter 3, problem 29. Let me make that bigger. A major league pitcher can throw a ball in excess of 34 meters per second. If a ball is thrown horizontally at this speed, so horizontally, so we know, once we hear horizontally, we derive the equations for horizontal motion. Any projectile that moves horizontally, we already derived the equations we need. So the first equation is the time of flight, square root of 2h over g, and then x, so this is h, and then distance x is v naught x times t. That's all, the two equations we need. How much will it drop by the time it reaches a catcher who is 17 meters away from the point of release? So we are given x to be 17 meters. Is that okay? And we are given the speed with which is thrown. They are asking for h. Again, the same problem. 17 equals v naught 35.4 times t square root of 2h over 9.8. So solve for h. So 17 divided by 39.4, square it. So let's do that. 36 divided by 17 divided by 35.4. 0.482, 480, square that. 0.231 or 0.2306. 2306 when you, after square is 2h over 9.8. So times 9.8 divided by 2 will give us h. Divided by 2, 1.13, exactly. 1.13 meters, and that solves it. Easy as taking a Fanta. You don't need to bother. You know the problem, you solve it quickly. You know the problem, you solve it quickly. So I put x here, I put v naught here, I put t for this guy, and that's how I solve it. Okay. So let's go. Next one. Chapter 3, problem 39. You are traveling in a convertible with the top down. The car is moving at a constant velocity of 26.1 meters per second due east or along the flat ground. You throw a tomato straight upward at a speed of 6.37 meters per second. How far has the car moved when you get a chance to catch the tomato? So how far? So they're looking for distance. So first of all, we need to get time. So let's see how much time is elapsed from when you throw it. So when you throw it, it comes back with the same speed. So if you throw with 26.1, it's going to land with 26.1. So I'm going to use that idea that v final y equals v initial y. So you throw it up. Is that okay? Minus gt. So v final y is just minus v initial y. So this minus 6, minus 26, minus 6.37. That's the one you throw straight upward. So minus 6.37 equals 6.37 minus 9.8t. So that's going to give us the time it will take the tomato to come back to you. So t is minus 6.37 minus 6.37 divided by minus 9.8. Okay? So let's do 6.37 times 2 divided by 9.8. 1.3 seconds. So it's going to take you 1.3 seconds for that tomato to come back. So how much distance have you moved? I know the speed you are moving, 26.1. So distance is just velocity times time. 26.1 times 1.3. That gives me the distance you've moved to catch that tomatoes, okay? 1.3 times 26.1, and that gives us 33.93 meters. As easy as taking a Fanta. You don't need to bother. Just simple. Simple as ABC. So we'll go to the next. Focus on concept question 01. An object is moving at a constant velocity. All but one of the following statements could be true. All but one. So which one cannot be true? 3 forces act simultaneously on the object. It's possible. When you move at constant speed, it means you're in equilibrium. What we call dynamic equilibrium, or kinetic equilibrium, or sliding equilibrium, also known as translational equilibrium. So when you're in equilibrium, it means your net force is 0, or you have no acceleration. These are all different definitions of equilibrium. You're at rest. 3 forces can act on you and you're at rest. They cancel each other. That's possible, like a triangle like this. So if I have a triangle like this, a force act here, another force act here, another force act here, and this triangle is equilateral triangle. If these forces are the same magnitude, F, this will be in equilibrium. So it's possible to move at constant speed in equilibrium, 3 forces acting on you. No forces act on the object. Very correct. You can have no force acting on you and you're moving at constant speed. From Newton's first law. A body at rest remains at rest. A body moving along a straight line continues its uniform motion at constant velocity or constant speed unless acted upon by a non-zero net force or an unbalanced force. Okay? A single force acts on the object. No way. If a single force acts on you, there's no how you can be in equilibrium. You need another force to counter you. 2 forces act simultaneously on the object. Yes. So the one that is not correct is C. That is why C is not correct. 1 force cannot give equilibrium. You need at least 2 forces to give equilibrium, or no force at all. Next. A car has a mass of 1600 kilograms. It is stuck in the snow and is being pulled out by a cable that applies a force of 7560 Newton due north. The resistance of the snow and the mud also applies a force to the car, which has a magnitude of 7340 Newton and points due south. What is the acceleration of the car? So we need to do the net force. So one force is acting due north, and we have another force acting due south. Okay? So we're going to find a net force which is going to be due north. And then we'll get the acceleration, okay? So force on this car, due north, another force due south. The one due north is 7650 newtons. The one due south is 7560. 7560. The one due south is 7340 newtons. And the mass of this car is 1600 kilograms. So Newton's second law says that the net force is ma. Net force, the opposite direction, is 7560 minus 7340. That's my net force. Equals the mass 1600 times acceleration a. So acceleration a becomes this difference divided by 1600. So let's do that. So let's do 7560. 7560 minus 7340. 220 divided by 1600. 0.1375, 0.14 meters per second square. Simple as ABC, simple as taking a Fanta. Yes, I love Fanta. So let's go to question 05. 2 forces act on a moving object that has a mass of 27 kilograms. One force has a magnitude of 12 newtons and points due south. So let's start drawing that and picturing the problem, so we can easily picture the solution. So one force at 12 newton due south. So I have 12 newton due south. And the other force has magnitude 17 newton due west. 17 newton due west. South and west. What is the acceleration of the object? So there are 2 ways. So we know the mass of the object will be 27 kilograms. So there are 2 ways to find the net acceleration. You know that force is ma. So you can find the acceleration, force divided by, so A is force over mass. So you can do force over mass, get an acceleration due west. Force over mass, get an acceleration due south, and find the net acceleration. That is one way to do it. Another way to do it is to find the net force first. Is that okay? So this will be this 27. 17 divided by 27. Let me just do that for the first method to get the acceleration first. 17 divided by 27. 0.63 meters per second square. So that's the acceleration due west. 12 divided by 27. 0.44 meters per second square. That acceleration due south. So I get the net. So the net acceleration A net is 0.44 squared plus 0.63 square root. Okay, so I do that. 0.44 square plus 0.63 square. 0.5944. Take the square root of that. 0.77. So our acceleration is 0.77, exactly there. 0.77 meters per second square. So this is one way. Another way is to find the net force first. 17 square plus 12 square root, that's F net. So I do that. 17 square plus 12 square root. (17 square plus 12 square root). Square root of 433. 20.81. So my net force is 20.81 newtons. Then I divide my net force by my mass, I get my net acceleration. So that will be 20.81 divided by 27. So it will give us the same thing. So 20.81 divided by 27, 0.77. So either you find the net force and get the acceleration, or you find the acceleration of each and find the net acceleration, you are getting the same thing. So to get the direction, you get the angle theta. I can call it here. So they want the angle south of west. So this is the angle south of west. So I complete this. So tan theta is opposite, which is the y. This line, 0.44 is opposite. Adjacent is 0.63 over 0.63. So I get theta to be the inverse tan of whatever this is. 0.44 divided by 0.63. So I do that. 0.44 divided by 0.63, 0.6984. So the tan inverse of that is what? Shift tan of the answer I just got, 34.93 degrees. 35 degrees. So theta is 35 degrees south of west. Very correct, south of west. Okay, that's how you solve the problem. That's how you solve this problem. Next problem is an airplane has a mass of 3.36 times 10 to the 4 kilograms and takes off under the influence of a constant net force of 3.48 times 10 to the 4 newtons. What is the net force that acts on the plane's 81.7 kilogram pilot? So the force that the plane experiences is different from the force the pilot experiences. But the only thing that they have in common is, since the pilot is inside the plane, they have the same acceleration. They have the same acceleration. Is that okay? So I'm going to do this to show you how to solve this problem. So F net plane is mass of plane times acceleration of plane. F net pilot, pilot and plane start from P. Curly P equals mass of pilot, acceleration of pilot. Is that okay? Now, plane and pilot, they have the same acceleration. Acceleration of plane is the same as acceleration of pilot. So, I will solve for acceleration in both cases. It's F net plane over mass of plane. So, it will be the same as F net pilot over mass of pilot. So, that is the acceleration of pilot, that's the acceleration of plane, and they are the same. So this helped me solve the problem. So the plane has a net force of 3.48 times 10 to the 4 newtons. And the mass of the plane is 3.36 times 10 to the 4 equals, they are looking for F net pilot. And I have the mass of pilot to be what? 81.7. This solves the problem. That gives me F net pilot straight ahead. So 81.7 times this guy divided by this guy. So 81.7, 10 to the 4 cancels 10 to the 4. So I have 81.7 times 3.48 divided by 3.36. $81.7 times 3.48 divided by 3.36. 84.617, 84.62. So F net pilot, I call pilot row, 84.62 newtons. Easy as taking a phantom. As easy as taking a phantom. That's correct. So go to the next problem. Chapter 4, problem 04. In the amusement park ride, known as Magic Mountain Superman, powerful magnets accelerate a car and its riders from rest. So we start putting our parameters down. Once I hear from rest, I'm happy. My mind is at rest. Because once you travel from rest, my mind is at rest. It means your initial velocity V0 or VI is 0. So I'm just going to put my V initial to be 0. In a time of 8.7 seconds, they get to 33.3 meters per second. So V final, 33.3 meters per second in a time of 8 seconds. Okay? 8.76 seconds, actually. 8.76 seconds. The mass of the car and riders is that. Find the average net force. So we just need acceleration. V final minus V initial over time. Then we can get the net force to be mass times this acceleration. So this will be 33.3 minus 0 over 8.76. Then that will give us the acceleration. So 33 divided by 8.76. 3.77. Then the mass times that. 9.13 times 10 to the 3 is 9130. That's the mass times what I just got. 3.77. So 9130 times 3.77. 34393. Is that it? 34393 newtons. So that's 8.76. Okay. 9130 times the acceleration. Yeah. So let me make sure I'm doing this right. 33.3 divided by 8.76. I hope I didn't make any mistake in that solution. 3.8. So this is 3.8, not 3.77. I made a mistake here. So this is 3.8 meters per second squared for the acceleration. Then mass times acceleration. 3.8 times 9130. 34706. Perfect. 34706.51 newtons. And that solves it as the net force. Next problem says, two forces Fa and Fb are applied to an object whose mass is 18.1 kilograms. The larger force is Fa. When both forces point due east, the object acceleration has a magnitude of 0.967 meters per second squared. So let's do this. So when both forces point due east, the net force is the sum. When two forces are in the same direction, the net force is their sum. So I have Fa plus Fb equals mass times acceleration. Acceleration, I'll just put Ma. Is that okay? Ma, mass times acceleration is 18.1 times 0.96. 18.1 times 0.961. 967. Okay. So they're in the same direction, so my net force is the same due east. So I have Fa plus Fb, 18.1 times 0.967. So I do that. 18.1 times 0.967. 17.5. I call this equation 1. Then I continue my problem. However, when FA points due east and FB points due west, the acceleration is 0.86 due west. Due east again. So it means FA is greater than FB. So FA minus FB. So because it's going due east and FA is the one that is east, so east is going to win. So east will be positive, this one will be negative, equals 18.1 again times, what's the acceleration due east? 0.804. So I have FA minus FB. So this is my F net when one is going east and one is going west. 18.1 times 0.804. $14.524. I call this equation 2. Now I solve these two equations. FA plus FB equals 17.5. This was equation 1. If I add them, equation 1 plus equation 2, what will I get? FB minus FB we go. 2FA is the sum of that. So FA becomes 17.5 plus 14.574 divided by 2. So let's see what that gives us. 14.524. This is 14.5524. 5524. So that plus 17.5 divided by 2. 16.02. 0.026, so 16.03 newtons. Correct. Now if I subtract them, that's FA. To get FB, I can either put FA in any of the equation to get FB directly, or I just subtract the equation. FA minus FA will disappear, minus FB will be minus 2FB equals this guy minus this guy. 14.5524 minus 17.5 minus 2.9476. So the minuses cancel. So FB is just 2.9476 divided by 2. $1.478. 1.48 or 1.47 newtons. So that's how we get 1.5 newtons if you round it up. So that's the correct answer for that. We'll go to the last problem for this homework. Yeah, it's been a long homework. I'm having a headache already. Oh my. When a parachute opens, the air exerts a large drag force on it. The upward force is initially greater than the weight of the skydiver and thus slows him down. Suppose the weight of the skydiver is 850 newtons and the drag force has a magnitude of 1020 newtons. The mass of the skydiver is 86.67. Take upward to be positive. What is the acceleration? Oh, so let's see the acceleration of this guy. This is also easy. It's a direct problem of net force. So a diver is falling on the parachute. So this guy is the diver. He's holding on this parachute and falling down. So he has his weight to be 850 newtons. And there's another force pulling it up, the drag pulling it up, 1020 newtons. So up is positive, down is negative. So what is our net force? 1020 minus 850 equals MA. So the mass is 86.7 times A. We're looking for A. So what's 1020 minus 850? So we do that first. $170. So A is 170 divided by 86.7. 170 divided by 86.7. 1960. What did I do? 1.9607. Sorry. 1.961. I'm like, what's the calculator telling me? 1.961 meters per second. So it's positive. If the downward weight was greater, it would be negative. But the upward force is greater, so the positive direction is greater, so the answer is positive. Yeah, thank you guys, and I'll see you guys in the next recitation. Have a good one.